Okay, number one, solve the compound inequality. So when you're solving this compound inequality, you want to solve it as if it's an equation, and the goal for solving an inequality or equation is to get the variable by itself. So here's our variable in this term right here. We want that to get by itself. So we want to start by undoing this dividing by 2. So the opposite of dividing by 2 is multiplying by 2. So we're going to do that on both sides of this inequality. So on the left I have 2 times 0, which is 0, is less than or equal to, now that crossed out that 2, so now we have 2x minus 8 is less than or equal to 6 times 2, which is 12. Now again, we are trying to get this x by itself, so to start that, we'll continue to do that. We're going to then add 8. So that would cancel out, but I have to do it everywhere. So I'm going to add 8 on the right and add 8 on the left. So now 0 plus 8 is 8, is less than or equal to 2x, which is less than or equal to 12 plus 8, which is 20. Okay? Now, something that will help me, if you have a question, you can totally unmute your mic and ask the question. But if you don't have a question, it would help if you could mute your mic so I don't have to hear, get distracted by hearing the outside noise.
Anthony.
So again, if you don't have a question, because this review session is open to like everyone at the campus. So if you don't have a question, if you just mute your mic, that'll help me be able to work through this without hearing a lot of background noise. Okay, so now to solve for x, we're going to divide by 2. On the left, I have 8 divided by 2, which is 4, less than or equal to x, which is less than or equal to 20 divided by 2, which is 10. Okay? So this would be the solution for the compound inequality. Let's say we wanted to graph that solution. So we're going to draw a number line, and I need to have 4 and 10. So 4 is less than 10, so I'm going to put that on the left of 10. Okay, so what this is telling me is that the solution needs to be between 4 and 10, and it can also include 4 and it can include 10. So I'm going to use brackets at 4 and 10. I'm going to face them inward because this is telling me that x is between 4 and 10. So my graph will look like this. So I'm hearing that we are having new visitors for the review, which is awesome. Welcome. If you could please mute your mic if you don't have any questions, that would help me out a ton. Thanks so much. Okay, so that's number 1. Solve the compound inequality. Let's look at number 2. We're going to solve another compound inequality with OR. So we're going to solve each individually first. So for the first one, I have negative 3x plus 8 is greater than 14. So I'm going to start by subtracting 8 on both sides. So on the left, I have negative 3x is greater than 14 minus 8 is 6. And then now I'm solving for x, so I'm going to divide by negative 3 on both sides. Now, it's super important to know that when you divide or multiply by a negative number, when you're solving an inequality, you have to flip the inequality sign. So on the left, the negative 3's cancel out, and I have x is less than, now, 6 divided by negative 3 is negative 2. So that's half of my solution. Now let me look at the next one. So I have x plus 1 is less than 5. So I'm going to start solve for x by subtracting 1 on both sides. Oh, not 4. 1. And this one's pretty simple. I have x is less than 5 minus 1 is 4. So these are my inequalities that make my solution. And so it's an OR compound inequality. Let's graph these. So I'm going to use some colors. Let's make this yellow. So I've got negative 2 and 4. So x is less than negative 2. So all of my values less than negative 2 are to the left. And then it's not including negative 2 because I don't have a line underneath the less than. So I'm going to use parentheses. So this is x is less than negative 2. And let's look at x is less than 4. So all of my values less than 4 are to the left of 4. So I'm going to shade all the way to the left of 4. And then I am not including 4 because it is not equal to, so I'm going to use parentheses. So this is x is less than 4.
Lauren Anderson.
All right. Great. I'm hearing new people join. That's awesome. If you could just mute your mic unless you have a question, that would help me out a ton through these problems. Okay. So this is an OR compound inequality, which means that the solution needs to include the union, everything. All right? So the solution on a graph for a compound inequality, an OR compound inequality, tells us that we don't need to only have where they intersect. We want to include everything as part of our solution. So basically, we want to include everywhere that's shaded, even if it's not in common. So everywhere that is shaded would actually be everything less than 4. This would be your solution. Okay? I should probably draw that closer to the 4, like that. All right, so this is the solution for this compound inequality. X is less than 4. There's no need to include x is less than negative 2 because that's implied in x is less than 4. Okay? Now, if this compound inequality was exactly the same except this OR was an AND, then your solution would be different. Your solution would only be where they intersect, where they overlap. But it's an OR compound inequality, so we want to include everything for our solution. This or that will work. Okay? So I have a question. Yes, someone asked, am I going to post this video as well? So for my online students, I am definitely going to post the video, probably tomorrow, for my online students to see. For everyone who has joined here, I believe you had to type an email for you to join. I plan on sending everyone an email of the link. I can send a link to your professors, and then you can ask them to post it, but I won't be able to post if you're not in my class, and I won't, be able to post in your class. Or you can always email me, and I can send you the video, the link to the video. My email is jforsthe3@valenciacollege.edu, and I can post that later. Oh, great! All right, you're in my class. Yeah, you'll get it for sure. Okay. Alrighty. So let's keep going. Number 3. Solve the absolute value equation. So for the absolute value equation, we want to get the absolute value expression by itself first. So right now, this is my absolute value expression, the absolute value of x plus 3. That's not by itself. That has a plus 18 there, so we want to move that plus 18 and make it go away and subtract 18 on both sides. So I have the absolute value of x plus 3 is equal to negative 17. Now you want to pay attention to absolute value. The absolute value of something is going to always give you a positive number because the absolute value is the distance that number is, or that expression is, from 0. And distance is never negative. You can never have a negative distance. Alright? So if you ever have an absolute value expression set equal to something that is negative, then that would be no solution. Okay? So this can never happen. The absolute value of x plus 3 can never equal a negative number. So this would be no solution. And sometimes you have to do a little work before you can determine that. Like in the beginning of the problem, you know, you wouldn't know it's no solution. But once you get that absolute value by itself, which is what we have here, we see that this is saying the absolute value of something equals a negative number. That's a no-no. That's no solution. Now, the thing is, you got to be aware of that, because you could totally keep going if you think, you know, this is an okay situation, an okay scenario. You would do the whole split them off into two and then solve two different equations and get two different answers. But if you were to go back and plug those numbers into your absolute value equation, you actually will find that they are not true statements. So that's the answer to number 3. Let's look at another absolute value problem. I don't have another one. Oh, let me make up one. Let's see. I will make up one. Give me a second. Well, I'm not going to make it up. I'm going to look in my book. Let's see here. 8.2. No, 8.1. Let's go with this one. I'm going to call this 3A. The absolute value of 2x plus 7 over 3 equals 7. Okay, so let's do another absolute value. So this one, the absolute value of 2x plus 7 over 3 equals 7. So this is okay to continue working because it's equaling a positive number. So we're going to split it off into two equations. So the first one, we're going to drop the absolute value and write the left side exactly as it is, and write the right side exactly as it is. Then for the second equation, we're going to write the left side exactly as it is, but then we're going to negate, set it equal to the opposite of the right side. So that'll be negative 7. And then we just solve them each individually. So for the first equation, I want to do the opposite of dividing by 3 by multiplying by 3 on both sides. So on the left, I'm going to have 3 times 2x, which is 6x. 3 times 27 is 21. Okay, equals 21. Okay, oh, what am I doing? No. What am I doing? I'm not going to distribute. Sorry about that, guys. Okay, so I am going to multiply by 3 on both sides, but doing that cancels out this 3. So on the left, I'm just going to have 2x plus 7 equals, on the right, 21. There we go. That makes way more sense. Now, if you guys see me do anything weird that doesn't make sense, yell at me, type something in the chat, let me know. All right? Because I'm human just like you, and I make mistakes, and we got to hold each other accountable. Okay, so we're solving for x. I'm going to subtract 7. I'm going to try to keep this on one page. It's a struggle for me because I write big. I have 2x equals 21 minus 7. It's going to give me 14. And then to solve for x, I'm going to divide by 2. So x equals 14 divided by 2, which is 7. So that's one solution. Now I want to do this other equation and get the other solution. So the same thing, I'm going to multiply both sides by 3. That's going to cancel the 3 in the denominator for the left side. So on the left, I'm going to have 2x plus 7 equals negative 7 times 3 is negative 21. And then now I'm going to solve for x. So to start doing that, I'm going to subtract this 7 from both sides. And so I'm going to have 2x equals negative 21 minus 7 is negative 28. And then divide by 2 to solve for x. So x equals negative 14. And these are my two solutions. X equals 7 and x equals negative 14. Why does that get so weird there? Okay. Okay. Number 4, find an equation of the line passing through the points -5, 5, and 2, -2. So something to know, there's two really important things you need in order to find the equation of any line. And that's going to be the slope of that line. Let me try to write neat. The slope of that line, and then you're going to need a point on that line. If you have those two things, then you have enough information to write, to come up with the equation of the line. So all we have here, we have 2 points, so we've got more than enough points to work with. We don't have a slope. So in order for us to get the slope, we're going to have to use the slope formula. So that slope formula, we say that's m equals y2 minus y1 divided by x2 minus x1. And all that is that you're subtracting your y values and then dividing it by the difference of your x values. So it may help you to label your points. So we'll call this x1, y1 because that's the first point. This can be x2, y2 because that's the second point. So y2 will be -2 minus y1 is 5 divided by x2, which is 2, minus x1, which is -5. Be super careful with your signs here. Okay? So -2 minus 5 is -7 divided by 2 minus a -5 minus a negative turns to just positive. So 2 plus 5 is 7. And -7 divided by 7 is -1. So we have the slope of this line. The slope is -1. So I'm going to say m equals -1. So now I have the slope and I have 2 points to work with. So now I just pick one of my points to then find my equation. So it doesn't really matter what point we use. I'm going to use this point here just because the numbers are a little smaller. It does not matter which one we use. So we're going to use, since we have a point and a slope, we're going to use what's called point-slope form. Okay? So that point-slope form is y minus y1 equals m times x minus x1. And just for the sake of consistency, I'm going to use the first point just because it'll match my x1 and y1. But you don't have to use the point that you labeled x1 and y1 in point-slope form. I could use x2, y2. The x1 and y1 here are just here to make sure you know that's where you plug in your points. Alright? X1 is not the same thing as x. So I don't want you to think I have to use this first point. But I am, just to make it consistent, just so you guys kind of know where everything came from. Alright? So I'm going to plug in my x1, my x coordinate, my y coordinate, and I'm going to plug in my slope that I found, and I'm going to simplify, and I want to put my final equation into slope-intercept form. So remember, slope-intercept form is y equals mx plus b. Okay? Now, so let's plug in. So we have y minus my y coordinate of the point that I'm using, which in this case is 5, equals m. The slope is -1 times x minus the x coordinate of the point I'm using, which is -5. So now in this parentheses, x minus a negative, that simplifies to x plus 5. So on the left I have y minus 5 equals -1 times x plus 5. Then I'm going to distribute this -1. So -1 times x is -x. -1 times 5 is -5. So I have y minus 5 equals -x minus 5. And then I'm going to put it in slope-intercept form. So I'm going to add 5 to both sides. So I'm going to end up with y equals -x, and then -5 plus 5 equals 0. So we could just say that's y equals -x. and that is my equation of the line. So you do need to remember slope-intercept form. You do need to remember point-slope form. Okay? And you do need to remember the formula to find the slope given 2 points. Okay? Alright. Number 5. Find an equation of the line passing through the point 9, 7 and perpendicular to y equals negative 3x minus 4. So remember I said you need a slope of the line and you need a point on the line. So which one of these are we given right now? Well, we're definitely given the point. Good. But we need the slope. Now it gives us information to help us get the slope, but we don't just automatically have it yet. What we do know is that the equation of the line is perpendicular to this equation that they give us. So perpendicular slopes are opposite reciprocal slopes. Reciprocal slopes. Alright? So the slope of this equation here is, so the given slope equals negative 3. So the perpendicular line slope that we need is going to be the opposite sign, so it's going to be positive, and then we're going to flip and get the reciprocal of 3. So it's going to be a positive 1 over 3. And that is going to be what we're going to use in our equation. Okay? Just so that you know, another way you could do it, if this problem was the same, but it said it's parallel to y equals negative 3x minus 4, then that means that we would use that exact same slope, because parallel lines have the same slope. Perpendicular lines, they're crossing at each other at a 90-degree angle, they have negative or opposite reciprocal slopes. So now we've got what we need to write our equation. So we have a point and a slope, so we're going to use point-slope form, which is y minus y1 equals m times x minus x1. So the x1 and y1 is just where we're going to plug in our x and y coordinates from the point that's given to us, or that we have, and the m is your slope. So we're going to have y minus 7 equals 1/3 times x minus 9. Okay, that came from your point and then the slope. And let's put that into slope-intercept form. So we're going to start by distributing this 1/3. So 1/3 times x is 1/3 x. 1/3 times negative 9 is negative 9 over 3, which would be negative 3. So on the left I have y minus 7 equals, and then to put it in slope-intercept form, which, remember, that is y equals mx plus b. We're going to add 7 to both sides. So y equals 1/3 x, then negative 3 plus 7 is positive 4. And that's going to be our equation in slope-intercept form. Okay, number 6. Find the equation of the line containing the point 2, 7, and parallel to negative 5x plus y equals 3. So very similar as the previous problem, we need a slope and a point. We are given a point 2, 7. We need a slope. So what we do know is that the line that we want to get an equation for is parallel to negative 5x plus y equals 3. But we can't look at that right now and just pull out that slope because we need to put that in slope-intercept form. So first let's put this in slope-intercept form by adding 5x. And then when we do that, we'll have y equals 5x plus 3. So now I have this line slope, and because my equation of the line needs to be parallel to this equation, I'm going to use that exact same slope. So the slope that I'm going to use is 5. Because remember, slope-intercept form is y equals mx plus b. And then m is your slope. And then b is your y-intercept. So we've got the slope of the line that we need, which is 5. So we've got our two pieces of information. Now we can write our equation. So y minus y1 equals m times x minus x1. So we're going to plug in our x-coordinate and y-coordinate and then plug in the slope. So we have y minus 7 equals 5 times x minus 2. And that was my x, wrong color. That was my x-coordinate and y-coordinate, and this was the slope. So let's simplify this and put this in slope-intercept form. So I'm going to distribute this 5, so that's going to be 5 times x, which is 5x. 5 times negative 2 is negative 10. Y minus 7 equals 5x minus 10, and to put this into slope-intercept form, I want to get the y by itself. So I'm going to add on both sides the 7. So I have y equals, bring down that 5x, and negative 10 plus 7 is going to be negative 3. So my equation is y equals 5x minus 3. Okay? All right. Number 7, find the domain of the function g of x equals 33x over negative 10x minus 20. Okay, so when you're finding the domain of a function, there's like 2 red flags you want to look for. The domain of a function, we can start off by thinking it's all real numbers. So there's no real number that would cause this function to be undefined or, undefined. But unless you have one of two things, or both things. So remember, you never want to have a 0 equaling your denominator, because you can't divide by 0. That gives you an undefined answer. You can even ask Siri. She'll tell you. Anything divided by 0 is undefined. So we never want the denominator. If we have a variable in the denominator, we never want that to equal 0. We do not want to include any x value that could cause the denominator to equal 0. If there exists a real number that if you plug it in for x, the bottom equals 0, we want to throw that out of the domain. We want to exclude that. That's an excluded value. The other scenario is that real numbers cannot come from having a square root of a negative number or an even root of a negative number. Now, you have learned what they do create. They do cause imaginary complex numbers, but we're only talking about the real number system here for this problem. So the 2 red flags are if you have a denominator with a variable, we want to exclude any values that could make that denominator equal 0. And then the other red flag is if you have even roots. In this case, it would be probably a square root. We don't want what's under that square root to be less than 0, to be negative. So if you don't have one of those things going on, your domain's all real numbers. No problems. Easy breezy. But for this problem, we do have a denominator, and it does have a variable. So in order to figure out what the domain would be, let's find the excluded values first. So basically, we want to figure out what values do we want to throw out of the domain. And that's going to tell us the domain is everything except those values. So in order to do that, you take the denominator, in this case it's negative 10x minus 20, and we set it equal to 0. By doing that, that's going to tell us what does make the bottom equal 0. So we know exactly what to exclude, what to throw out of our domain. So we're going to just solve for x here. So to start that, I'm going to add 20 to both sides. So negative 10x is equal to 20. And I'm solving for x. I'm going to divide by negative 10 on both sides. So x equals 20 divided by negative 10 is negative 2. So what that means is that if x were to ever equal negative 2, we would end up with, what, negative 66 over 0. And that's undefined. So for this function, our domain is everything except negative 1. So let's look at what that would look like on a graph, right, on a number line. So I've only got one excluded value, so I'm going to throw that right here in the middle. So if I wanted to say the domain is all real numbers, that's basically like shading the entire number line, right? It's shading everything in the number line. But we have an excluded value. We do not want to include negative 2. So it's everything except negative 2. So the domain is everything. It could be negative 1, it could be 1.2, it could be negative 16.5, it can be, 4 2/3, it can be negative 1/2, it can be anything except negative 2. And why is that? Because negative 2 will give you a 0 in the denominator. So I like to graph this scenario because it makes it a lot easier to then go to interval notation, because that's what we want our answer to be in. So on the number line, remember that the very left side of that number line with the arrow represents negative infinity. And the very right side of that arrow, of that line, represents positive infinity. It's going on and on and on and on forever both ways. So interval notation, you always write your interval from left to right. All right? So everything from the left should be less than everything on the right. So the most left part of this interval, and what we have are two different intervals. We have this interval here, and then this one here. So the first interval is going to start at negative infinity. And you always use parentheses by infinity. Always. Comma. That comma represents from this first number, comma, all the way to what? Negative 2. Now, I am not including negative 2. Negative 2 cannot be in my domain, because remember, that gives you a 0 on the bottom. We want to exclude that. So I'm going to use parentheses because I'm not including negative 2. If negative 2 could be part of my domain, I would use a bracket because I'm including it. Now I have another interval, so I'm going to use a union, and then I'm going to start at this interval. It starts at negative 2, but not directly negative 2, so I'm going to put a parentheses, comma, all the way to infinity. And remember I said you always use parentheses by infinity, so there we go. So this is the domain in interval notation. Interval notation is super, super important in this class, and you're going to need it in college algebra and beyond. It's one of those concepts because it's a way to describe a large region very simply. All right? So that's your answer. Okay, let's find the domain of a function when you have a square root. So remember I said one scenario was when you have a denominator and the bottom can equal 0. The other scenario is if you have a square root. You never want that to be the square root of something negative. So right now it's the square root of something unknown. The unknown is negative 6 plus 8. The way to figure out the domain is to set the radicand, which is what's under the square root, set it greater than or equal to 0, because that will tell you what your domain can be. Because this is okay. What's under the square root, that can be 0 and it can be greater than 0. So we're going to take that negative 6 plus x and set it greater than or equal to 0. And then we're going to solve. So if we solve for x, we're going to add 6 to both sides. So I have x is greater than or equal to 0 plus 6, which is 6. So what this means is that your domain is greater than or equal to 6. That's your domain. And let's graph that and then put it in interval notation. We're going to plot 6 here in the middle. X is greater than 6. So all of my numbers greater than 6 is to the right of 6, all the way to infinity. And then I am including 6 is greater than or equal to, so I'm going to use a bracket. So that's my graph. And now in interval notation, the shaded region, I only have one interval to write out. You always start on the left part of the interval. So it starts right here at 6. And I do include 6. I'm going to use a bracket, comma, all the way to infinity. And then you always use parentheses by infinity. And that's going to be your domain in interval notation. Okay. Number 9. So now we're talking about chapter 2 now. Solve the system of equations by the addition or elimination method. Okay, so in order to do this, you want to add your two equations so that one of your variables are eliminated or cancel out. One of your variables are eliminated. And the way that you do that is that you want to either find the variables that have opposite terms or create opposite terms. Which variables you eliminate is completely up to you. I'm going to look at my system here, and I'm going to try to get rid of the x terms. So here are my x terms right here. X and 3x. So right now, if I were to add that together, I'll get 4x. That does not eliminate. I want that to be 0x, no x, go away. The only way they're going to add up to go away is if they're opposites of each other. So like 2 and negative 2 added together gives you 0. X and negative x gives you 0. Added together gives you 0. Negative 3x, positive 3x, if you add them together, you'll get a 0. So I want to create that here. So if I'm trying to get rid of the x terms, I'm going to multiply this first equation by negative 3. And why am I doing that? Because when I do that, negative 3 times x is negative 3x. Negative 3 times y is negative 3y. Negative 3 times negative 3 is positive 9. The whole reason why I did that is because when I add now these two equations together, let me use a different color. When I add these two equations together, my x terms are going to cancel now. That was my goal because I wanted it to be that. You could be doing it at home and say, I want my y's to go away first. So in order to do that for this problem, you would multiply the top one by negative 4, and the y's would go away. So when I add here, 3x plus negative 3x is 0x. 4y plus negative 3y is the same thing as 4 minus 3, which is 1y. And then negative 7 plus 9 is positive 2. So 1y is the same thing as y, so y equals 2. So the system of the solution to a system of equations describes where those two lines or where those equations intersect, or if they don't ever intersect, or if they infinitely intersect. So in this case, they are going to intersect at a point, and so that point is, as you know, x comma y. That's your solution. So what did we find? We found the y coordinate, which is 2. But I have to get the x coordinate of my solution. So the way that you do that is you take one of your original equations. I'm going to take the first one because it's a little simpler. X plus y equals -3. And we're going to plug in y equals -2 into that equation. So x plus 2 equals 3. And then to solve for x, I'm going to subtract 2 from both sides, so x equals 3 minus 2, which is 1. So that is the x coordinate of your solution. So the solution to this system of equations is 1, 2. And what that's telling us is that if we were to graph both of these equations, we get two lines that intersect at the point 1, 2. Okay? All right. Number 10, solve the system of equations by the substitution method. Okay, so to solve using substitution, we want to take one of our equations, set them equal to a variable, and then take that entire expression and plug it into that other equation's variable. Sometimes it's already set equal to a variable, and this method is easier for us. Which in this case, we do have that. We already have an equation set equal to a variable. Y equals 7 over 5x minus 3 over 5. So I'm going to take what that equation said equals y. I put it in a red box. I'm going to plug it into the other equation for y. Because y is y. Like the y in the first equation is the same y in the other equation. So let's see what happens. So I'm going to have 7x minus 5 times y, which is 7 over 5x minus 3 over 5 equals 8. Okay, so let's see what happens. 7x. Now I'm going to distribute this -5. -5 times 7 over 5x, and then -5 times -3 over 5 equals 8. Looks like I have a question. I don't understand how you got 1 for x. That's probably for the previous problem. Let's go back really quick. She had a question about how we got 1 for x. Oh, you're exactly right. I rewrote that problem wrong. That's x plus y equals -3. Good catch, Lauren. Thank you for that. So I wrote this wrong. And pro tip, when you're doing your test, I almost find almost all of my students leave like a solid hour left on the clock when they leave after taking the test. Take the time to double check your work. You have plenty of time to do your final exam, really for any test. So I would have missed this problem, not because I don't know the steps, because I just wrote the wrong thing. This equation is x plus y equals -3. I wrote x plus y equals 3. That's -3. So that means that when I subtract 2 here, I should get -5, not +1. So my system solution is -5, 2. Very good catch. Thank you so much for that. So please do that when you take your tests. Don't be in such a rush, because you'll miss problems for reasons that it's not fine. You know, that's painful to miss a problem because you just missed the negative, like literally didn't even write it down. So anyway, I digress. Thank you so much for that. Okay, so now let's see what we got. So bring out that 7x. So the 5's cancel here, and I have negative 7x. And then here, this 5 cancels, so I have negative times a negative is a positive 3 equals 8. So now I have 7x minus 7x is 0x, so I have 3 equals 8. And whenever this happens, that means, so 3, does that equal 8? Of course not. So if that happens, that means we have no solution. Okay? And what's happening is that your lines are never intersecting. They're parallel to each other. They will never ever intersect. So that means they never cross, they never touch, so it's no solution. And you're done. But this has to happen, this kind of scenario must happen in order for you to have a no solution system. So these are parallel lines, never touch. Hope y'all can read that handwriting. Okay. Number 11, to solve this system. So we're going to use whatever method we want, and I'm going to use substitution because it's already kind of set up for us to do that. So x equals negative 5y minus 1. I'm going to take what I boxed in and plug that in for x in the other equation. So I have negative 3 times negative 5y minus 1 minus 15y equals 3. So now I'm going to distribute that negative 3 with that negative 5y, which would be negative positive 15y. Then negative 3 times negative 1 is positive 3 equals negative 5, not equals, minus 15y equals 3. Okay, so let's simplify on the left side. I have 15y minus 15y. That cancels out. And I have 3 equals 3. What does 3 equal 3? Yes, it does. That's a true statement. So that means we had infinitely many solutions. What that means, and I think in MAT1033C you're going to type infinity to say that's your solution for both spots. And what that basically means is that both of those lines are both of those equations are the same line. It's just like a equivalent equation. So if you were to graph the first line, you would get the graph of the second equation. It's the same thing. It's like two lines laying on top of each other. Alright? And you're done with that one. That's it. Okay, number 12. In 1 year, Michael earned $6,300 as a work study in college. He invested part of the money at 9% and the rest at 7%. If he received a total of $493 in interest at the end of the year, how much was invested at 7%? How much was invested at 9%? So this word problem is a little lengthy, but if you practice it, you'll kind of get the gist of what to do. All these problems, you probably will see a problem like this. You have a few of this in your book. There are some videos in your course. This one uses the interest formula, I equals PRT. The interest earned equals the P, the principal, which you deposit or which you invest, times the rate, times the time in years. So for this, you have two accounts here, right? You've got, or two investments. You have one investment at, so I'm going to say I equals P times R times T. Alright, so you've got one investment. The table helps me organize my information. Okay, you got one investment at 9%. One investment at 7%. Okay, so let's fill in what we know in our table. So we've got, he earned $6,300 as a work-study student in college. He's going to invest all of that. Okay? I'm going to make this bottom row the total. His total investment is $6,300. So that's going to be the deposit, total deposit here. So, okay, let's see what else. So he invested part of the money at 9%, the other part at 7%. So we're going to put 9% under the rate for the row for 9%. We're going to put that as a decimal. So we're going to say 0.09. And then we're going to put 7% here, 0.07. He received a total of $493 in interest. So the total he got in interest is $493 after 1 year. So the time for both is just 1 year. How much was invested at 7%? So what was his principal at 7%? We don't know. We're going to put a variable. I'm going to put Y just because it's second in my column. And then how much was invested at 9%? We'll say that's X because we don't know what that is. It's an unknown. It's a variable. So these two columns are going to give us our equations for our system. But we're missing information here for the interest. But to get that, we're going to use our interest formula. So remember, P times R times T equals the interest. And we have a P, R, and T for both of these scenarios. So X times 0.09 times 1 would be 0.09X. And then Y times 0.07 times 1 would be 0.07Y. So we've got our two equations. Do I have extra paper? Nope. Okay, let's see how neat I can write. Alright, so the first one will be use my red, 0.09x plus, because the total, 0.07y equals 493. And then for the other column, I have x plus y equals 6,300. So now you have your system here to solve. I would probably use substitution. You could be fancy and use elimination. It's up to you. Whatever floats your boat. So I'm going to use substitution. I'm going to work with that second equation, and I'm just going to say eeny, meeny, miny, mo, and pick a variable to solve for. I'll solve for x. So that'll be x equals 6,300 minus y. I'm going to take this expression that's equal to x, because this x is the same x in the other equation, plug it in here. Let me get some extra paper. Okay. Let's see. Oh, I did it. Yay. Okay. All right. Where was I? Oh, okay. So 0.09 times 6,300 minus y plus, oh, where's my black? Plus 0.07y equals 493. Okay, so we're going to distribute that 0.09. Now remember, you're in intermediate algebra, so use your calculator. It's okay. 0.09 times 6,300 is going to equal 567. Yeah. And then 0.09 times negative y will be negative 0.09y. Bring down the plus 0.07y equals 493. All right. So now we're going to add like terms on the left, which will be here. Negative 0.09 plus 0.07 is going to be negative 0.02 y. Let's bring down that 567 equals 493. And we're solving for y, so we're going to subtract 567 on both sides of the equation. 493 minus 567 is negative 74. So I have negative 0.02y equals negative 74. And so to solve for y, I'm going to divide by negative 0.02 on both sides. So y equals positive 3,700. Okay? So it's important to label what your variables mean. So I have a table to kind of help me reference, but make sure, because I've seen people that you all will get the two correct numbers and assign them to the wrong account. So just be very careful with that. So now I want to get x. So that's my y. Let's take our simple equation here, x plus y equals 6,300, and solve for x. So I'm going to take 3,700, plug it in for y. X plus 3,700 equals 6,300. Subtract 3,700 to solve for x. So x equals 2,600. So what does that mean? The question asked, how much did he invest at 7%? So I like my colors. 7% was y. So my y equals 3,700. So he invested $3,700 at 7%. And so at 9%, he invested $2,600. And then the total of those two equals what he earned at work study, $6,300. Okay? So now, and you don't have to do a table to do this problem. And that's why I was saying the more that you practice these, you can kind of see how you would set up the system in the first place, and you can bypass the table. But I find if you have trouble even coming up with your system here, the table may help you get there. All right? So, divide using long division. Okay, so long division I know is y'all's favorite thing in intermediate algebra. Just kidding. I would say the main thing to remember with long division is to take your time, okay? So do not, this is a problem that you don't want to rush through. Writing down everything helps. So you're going to see me write down stuff that's going to seem redundant, but it really helps to be organized with these type of problems. So when you do long division, you want to always check for any missing terms. So your exponents, your exponents should decrease in order. So for example, I have 4x to the 5th, then it jumps to x to the 3rd. So it's missing an x to the 4th. So this number at the top is going to be under the division bar. So 4x to the 5th, I'm missing that x to the 4th. So I'm going to put plus 0x to the 4th. And then I have minus x to the 3rd, minus 2x squared, minus 180x plus 14. Okay? Then the denominator, I'm missing a term there. I have x squared. I'm missing an x term. So plus 0x, then minus 7. So as I work through this, you may find that, oh my gosh, this is taking so long, but it's going to really help with the organization. Organization is crucial for these problems. So the way that you do these is that you're going to divide the leading terms and put the quotient in the top. So 4x to the 5th divided by x squared is going to give you 4x to the 3rd. Okay? Then you're going to multiply. It's just like long division with numbers. So 4x to the 3rd times x to the 2nd is 4x to the 5th. 4x to the 3rd times 0x is 0x to the 4th. And then 4x to the 3rd times negative 7 is negative 28x to the 3rd. Okay? So now we're going to subtract everything here. So you should always end up with the same term at first because you want that to cancel out. Alright? So 4x to the 5th minus 4x to the 5th cancels out. 0x to the 4th minus 0x to the 4th is just 0x to the 4th. And then negative x to the 3rd minus a negative 28 is the same thing as negative 1 plus 28, which is positive 27x to the 3rd. And we're going to bring down that negative 2x squared. Okay, so now we're going to go again. Take the leading term, 0x to the 4th divided by x squared. Basically, what times x squared will give you 0x to the 4th? And that would be 0x squared. 0x squared times x squared is 0x to the 4th. 0x squared times 0x. Oh, I'm using red for multiplying. Sorry. 0x to the 4th. 0x squared times 0x is 0x to the 3rd. And 0x squared times negative 7 is 0x squared. Now I know this may seem really unnecessary, but again, I like to write every step out because it helps me keep track of everything. So when I do that, I'm going to subtract. The first terms cancel out. 27x cubed minus 0x cubed is still 27x cubed. And then negative 2x squared minus 0x squared is still negative 2x squared. And I'm going to bring down that negative 180x. So now I'm going to take the leading terms, 27, got a little too excited with that. There we go. 27x cubed divided by x squared. That's basically asking what times x squared will give you 27x cubed. That would be 27x. Then we're going to multiply. 27x times x squared, 27x cubed. 27x times 0x is 0x squared. 27x times negative 7 is going to be negative 189x. Now we're going to subtract everything here. So 27x cubed minus 27x cubed cancels out. Negative 2x squared minus 0x squared is still negative 2x squared. And then negative 180x minus negative 189x is going to be positive 9x. Then I'm going to bring down that plus 14. Then I'm going to divide again. Negative 2x squared divided by x squared gives me negative 2. Then I'm going to go back and multiply. Negative 2 times x squared is negative 2x squared. Negative 2 times 0x is 0x. And negative 2 times negative 7 is positive 14. Then we're going to subtract. So negative 2x squared minus negative 2x squared is nothing. 9x minus 0x is still 9x. And 14 minus 14 is 0. So I've got my answer here. So the quotient is 4x cubed plus 27x minus 2, and the remainder is 9x. Then the way you would write that, another way you could write that is that the answer is the quotient plus the remainder over the divisor. So for this problem, the answer would be 4x cubed plus 27x minus 2 plus 9x over, I don't remember what the divisor was, x squared minus 7. Okay? But like I said, you know, and you'll probably have one not quite as long on your final, but take your time. Be very, and you know, I struggle with writing neat. I don't know if you can tell. Hopefully you can. But if you can tell, I really have to concentrate. And this is a, whoa, sorry guys. Sorry about that. This is a problem where being neat is extremely helpful because there's a lot going on here. So really try to be neat and give yourself plenty of space when you do these problems. Okay, let's keep the party going. Number 14, let's practice factoring. Okay, so this is, so when you factor any polynomial, you always check for a greatest common factor, all right, so that you can factor out. So I have 8x cubed plus 27. So when you're looking for a greatest common factor, it's helpful to kind of focus on the smaller number because you're going to have less factors to think about. So you want to see if 8 and 27 have a common factor. And the only common factor that they have is the number 1. So there's not a GCF to factor out here. So the next step is to look at how many terms you have. I have 2 terms. So I either have the difference of 2 squares or I have the sum and difference of cubes. And it looks like I have the sum of cubes. So let's remember that formula. A cubed plus B cubed equals A plus B times A squared minus AB plus B squared. So the way that you do this is that you identify what your A and your B is. So 8x cubed is the same thing as 2x cubed because 2 cubed equals 8 and then x cubed is x cubed. So 2x cubed is the same thing as 8x cubed plus 27. So what to the third power gives you 27 is 3. So A in this case is 2x, and in this case the B is going to be 3. So you're going to plug in those values following the factor pattern. So 2x plus 3 times 2x squared minus 2x times 3 plus 3 squared. Just so you can follow along, I just plugged in my values just like that. Okay. So now we're going to just clean this up. So the left is just going to be 2x plus 3. Now, 2x squared. 2 squared is 4x squared minus 2x times 3 is 6x, And then 3 squared is 9. This is going to be your final answer. 2x plus 3 times 4x squared minus 6x plus 9. You do want to remember your factor patterns. Let's look at the other one, a cubed minus b cubed. That would be a minus b times a squared plus ab plus b squared. All right? So you want to be able to write those out. When you do your final, if I were you, I would memorize these, and as soon as you get your paper, write them all down so you can have them there as a reference. Okay, hold on. Okay, next, add or subtract the rational expressions and simplify. Okay, so in order to add or subtract rational expressions, you must have a common denominator. So, let's see here. Okay, so it's good to factor everywhere possible in your denominator. So we have x plus 1, x minus 1. X squared minus 1 is the difference of 2 squares. That's going to be x plus 1 times x minus 1. So you want for the denominator in all three of these to be the same. So that means that this first rational needs an x minus 1. So we're going to multiply the top and bottom by that. And this one needs an x plus 1. So we're going to multiply the top and bottom by that. So when we add that up, we're going to have that same common denominator of x plus 1 times x minus 1. That's our least common denominator. Alright. So now let's see what we have. So we have 5x times x minus 1 plus 6 times x plus 1 minus 10. You can't really see that minus in there, but that's there. So let's see what we have now. So we're going to distribute that 5x. So we have 5x squared minus 5x plus 6x plus 6 minus 10, all divided by x plus 1 times x minus 1. Let's combine like terms. So I have 5x squared, negative 5x plus 6x is positive 1x or positive x. And then 6 minus 10 is negative 4 over x plus 1 times x minus 1. And then from here you want to see if you can factor the top, and if you're going to get a common factor that you have in the bottom to cancel out, then you would factor the top. Let's see, 5 times negative 4 is negative 20. That may be factorable. Let's see. So 5 times negative 4. Let me see if I can factor the top part. 5x squared plus x minus 4. So a times c is negative 20. I need two numbers that will multiply to give me 20 and subtract to give me 1. Let's see, so that'll be negative 5 and 4. So that'll be x minus 5, x plus 4, but I have to divide by 5. So that's going to be x minus 1 times, slide and divide, 5x plus 4. Okay, yeah, so here at the top we can factor. So I went through and factored the top trinomial. So what I used was the AC method and the slide and divide method. So I had 5x squared minus x, plus x. There I go again, writing stuff wrong. Hold on one second. So it's going to be the opposite. It's going to be a positive 5 and a negative 4. Positive 5, negative 4. Okay. So I did 5 times 4 is 20. The way that I set up my factors, I like to drop the first sign and then multiply the signs together to get the next sign. So now I need two numbers that multiply to give me 20 and subtract, because 20 is negative, to give me 1. That'll be 5 and 4. I'm going to put the 5 first because it's a bigger factor, so it's going to be a positive 5 and a negative 4. Because 5 times negative 4 is negative 20, 5 plus negative 4 is positive 1. But I have to take my A and divide both of these numbers by that A. Simplify where possible. So 5 over 5 reduces to just 1, so I have x plus 1. And then negative 4 over 5 cannot be simplified further, so I'm going to slide and divide. So I'm going to say that's 5x minus 4. So what happens is that I have at the top x plus 1. Let me use my gray. I have x plus 1 times 5x minus 4 divided by x plus 1 times x minus 1, and I have common factors I can cancel out, so my final answer is just 5x minus 4 over x minus 1. Okay? Alright, number 16. Oh, come on. I have a question. Okay, I got a question. Can you do one more of a similar problem? I'm pretty sure I'm going to get more factoring on here. Let me look. Maybe not. Do you have a factoring problem I can do? Because there's so many factoring problems, so I want to do one that you would like to see. So let me get some extra paper. So I got a request for another factoring problem. So, or you can give me kind of exactly what kind of factoring you wanted me to do, then I can find one. So what type of factoring are you wanting to go over? Technical difficulties. Okay. Alright, let's see what we've got. You can type it out, or you know a problem. Is it, you can type it or you can say it. Yeah, whatever you want to do. But there's just so many different factoring problems. I just want to do what you want. Okay. Oh, that's not factoring. Okay, so you want some with adding rationals. Okie dokie. So I think you've got, no worries. Alright, 3x, hold on, 3x minus 1 over x minus 1, 4 over x minus 1, plus 6. Okay, is that what you have, Anthony? Alright, cool. Alright, so We're not going to say that's factor. We're going to say that's more rationals. Okay, so again, to add or subtract rational expressions, we have to have a common denominator. So right now we have different denominators. The first rational has a denominator of x minus 1. The second has an x minus 1. The third has an x squared minus 1. So you want to make sure all the denominators are factored so you can really see what factors you have to work with. So the first two you can't factor. So what you see is what you get. The last one is factorable. So the last denominator is actually x plus 1 times x minus 1, the difference of squares. So we want for all of these rationals to have the same thing in the denominator. Just like if you had like 1/2 plus, oh my gosh, why is it doing that? Okay, just like if you had 1/2 plus 1/3. You couldn't add that unless they had the same denominator. So you would have to multiply them by something to make them both have the same denominator. So I can make these both be a 6 by multiplying this by 3 and this by 2. So I do it to the top and the bottom, and I end up with 3 over 6 plus 2 over 6, and now I can add them up, right? Same idea here. I can't add these until they have the same thing in the denominator. So so x minus 1 can turn into x plus 1 times x minus 1 if I multiply it by x plus 1. Then look, it's the same thing as what I have here in the red. But if I multiply the bottom by that, I have to multiply the top by that as well. Okay? Same thing here. I have an x minus 1. Actually, let me pause on that. There's no reason. Actually, let me pause, because first, if this is the problem that you were given, if it's x minus 1 and x minus 1, I can actually add this part together and make that one rational. So that'll be 3x minus 1 plus 4 over x minus 1 plus 6 over x plus 1 times x minus 1. Alright, so now it's a little easier to work with. So, back to what I was saying, I want them to have the same denominator. They're not quite there, but if I multiply this by x plus 1, then we are there. But if I multiply the bottom by that, I have to multiply the top by that as well. Okay? So the top part I have x plus 1 times, this is 3x minus 1 plus 4, so that's 3x plus 3. Alright? Plus 6, all divided by that common denominator that we now have. Okay? So now at the top, I'm going to FOIL, or distribute, x plus 1 times 3x plus 3. So x times 3x is 3x squared. X times 3 is 3x. 1 times 3x is 3x. And 1 times 3 is 3. Over x plus 1 times x minus 1. Alright, so now at the top I've got 3x squared plus 6x plus 3 over x plus 1 times x minus 1. I want to factor the numerator to see if I can cancel anything out. So in the numerator I have a GCF of 3 to factor out. When I do that, I have x squared plus 2x plus 1 over x plus 1 times x minus 1. And now I want to factor this trinomial. So I need two numbers that will multiply to give me 1 and add to give me 2, which would be 1 and 1. So I have 3 times x plus 1 times x plus 1 over x plus 1 times x minus 1. And now I can see I have common factors I can cancel out. Here's an x plus 1, there's an x plus 1. So my final answer will be 3 times x plus 1 over x minus 1. And that will be your final answer. So remember, your goal is that in order for you to add and subtract rationals, it's the same rules as adding and subtracting fractions. You have to have common denominators. Oh, no problem. Not a problem at all. Thank you for asking. Okay. Oh, I have a sneeze coming. Hold on. I didn't want to sneeze in y'all's ear. Okay. All right. Good deal. Okay, let's do this problem, solving the rational. Okay, so now, So now we're solving a rational equation. So there's a few ways you can do this. The way to kind of quickly get rid of any fractions is to find the least common denominator and multiply everything by that denominator. So in this case, we only have one denominator, and that's a p. If we multiply everything by p, then your denominators will go away. So I have p times p. Actually, I'm going to write out what we have. So we have p times p minus p times 40 over p equals p times 3. I distributed everything by p. Let's see what happens now. So p times p is p squared. The p's cancel here, and I have negative 40 equals p times 3, which is 3p. Now I'm solving this equation. It's a quadratic. I have p squared. So to solve it, I'm going to solve it by factoring. So I'm going to set it equal to 0. So I want to subtract 3p on both sides. So I have p squared. I'm going to put minus 3p next. Minus 40 equals 0. So let's practice factoring again. So we have p squared minus 3p minus 40 equals 0. So I like to factor this way. So this one, the leading coefficient is a 1. These are easier trinomials to factor. You don't have a GCF to factor out. So I'm going to start to set up my factors. So I know it's going to be a p and then a p. And I'm going to drop this sign to get the first sign, and then multiply these two signs together to get the next one. So drop the negative, and then negative times the negative is a positive. So now I need two numbers that will multiply to give me 40 and subtract, because the 40 is negative, to give me 3. So it's going to be 8 and 5. And then if I use these sign rules, I'm going to always put the bigger factor first. So 8 and 5. Okay? And I have factored this, but I'm solving it. So once I have factored it, I'm going to take my factors and set them equal to 0. And then solve each one for p, and that's going to give me my solutions. So I have p equals 8, and then I have p equals negative 5. And those are my answers. Okay, let's look at the next one. So we're going to rationalize this denominator. Okay, so in order to rationalize the denominator, you want to multiply the top and bottom by the conjugate of the denominator. So that would be, in this case, 4 minus the square root of 7. So we have negative 27 over 4 plus the square root of 7. And we're going to multiply the top by 4 minus square root of 7, and the bottom by 4 minus square root of 7. Okay, so the top we're going to basically have negative 27 times 4 minus the square root of 7. Now on the bottom we're going to distribute. So I'm going to have 4 times 4. I'm going to have negative 4 root 7, positive 4 root 7, and then negative root 49. Okay, so at the top I'm going to have negative 27 times 4 is negative 108. And then negative 27 times negative root 7 will be a positive 27 root 7. Now in the bottom, 4 times 4 is 16. Negative 4 root 7 plus 4 root 7 is no root 7, cancels out. And then what's the square root of 49? Well, that's 7. So I have negative 7. This equals 7, so it's a negative 7. Okay, so now I have negative 108 plus 27 root 7 over 16 minus 7 is going to be 9. Now you want to check and see if you can simplify this. And the best way to kind of look at that is to split it up. So you've got negative 108 over 9 plus 27 root 7 over 9. So you want to see if you can simplify this. So I want to make sure you're comfortable using the graphing calculator, because that can help you get through some of these problems. And y'all see my calculator. I think you should be able to see it. Yeah, I think you can see it. Wait, it went away. Okay, so how do I know if I can simplify negative 108 divided by 9? The calculator can help you with that. So if I were to say 108 over 9, that gives me 12. So that is helpful. Okay? Let's do 27 over 9. That gives me 3. So this actually can reduce nicely. Okay? So this would actually reduce and give me negative 12 plus 3 root 7. Now you can't simplify that root 7. That's not just a 7 by itself. That's the square root of 7. And sometimes when you get to this point here, maybe you can't divide everything by the denominator, but what if you could divide these three numbers by the same number and just reduce it further? You would definitely want to do that. Okay? So that's your final answer. Negative 12 plus 3 root 7. Okay, let's look at the next one. So multiply and express your answer in scientific notation. So, you know, just keeping it all the way straightforward with you guys. You can use a calculator, so don't hesitate to do that if you get stuck on this. Or we're also going to use this using math. Okay, so to multiply, I'm going to start by multiplying 5.8 times 7.5. All right, 5.8 times 7.5 is 43.5. Okay, times 10 to the negative 43 times 10 to the negative 18. Cool thing about this is that multiplication is commutative. So you could rearrange these numbers all different types of ways and get the same answer. So this is 43.5 times. Now they have the same base. You have the same base. What do you do with the exponents? You add them. So negative 43 plus negative 18 is negative 61. Okay? But is this answer in scientific notation? No, it is not. Okay, it is not. This needs to move one decimal to the left. All right. So, by moving that decimal place 1 to the left, that makes this 4.35. But when we do that, that's like, think about that as if you are dividing it by 10. All right? So, if you think about it, how would I explain this to you guys? Let's see right what I have. Oops, nope. Okay, so when you move that decimal 1 to the left, you want to also include that 10 to the first there. All right, because 4.35 times 10 to the first would tell us that we would move that decimal place 1 to the right to give us 43.5. So we're basically taking what we're doing. Let me explain that better. What we're doing is that we're taking 43.5 and writing it in scientific notation. So in order to do that, we'd move the decimal 1 to the left, 4.35, and that'll be times 10 to the first. Okay? So when we do that, we have to compensate for that and include that here. Oh, where'd it go? Come on, Word. All right. Okay. So when we do that, we've got 4.35 times, again, we have the same base, so we can add the exponents. So negative 61 plus 1 is 10 to the negative 60. And that's your final answer. Let me make sure I put that here. 10 to the negative 43 plus negative 18 equals 10 to the negative 61. Okay, and that's your final answer. Okay, simplify the complex fraction. Okay, so there's a couple of ways you can do this, but I think the quickest way to do it is to what they do call clearing out the fractions. So you look at all of the denominators that you have here. So we have a 7 and we have a 3. If we find the least, oh goodness, the least common multiple between 7 and 3 and multiply the top and bottom by that, then we can end up getting a simpler fraction to simplify. So if we have 7 and then we have 3, the least common multiple would be 21. So let's multiply the top and the bottom by 21. And 21 over 21 is just 1, so we're not even changing the value of this. We're just multiplying it by an equivalent fraction to 1 to help us manipulate it. So basically we have 21 times 6 over 7 minus 21 times x over 21 times 5 over 3 plus 21 times x. Let's see what happens. So we've got 21 over 7. 7 divides into both of these. 7 divides into 21 3 times and divides into 7 1 time. So I would have 3 times 6 minus 21x at the top. And at the bottom, let's see, 3 goes to 21 7 times. So I have 7 times 5 plus 21x. And so to clean this up, 6 times 3, 3 times 6 is 18, minus 21x over 7 times 5 is 35 plus 21x. And let's see if we factor any common factors out, if we will get anything that can cancel. So 18 and 21 have a common factor of 3. So if I factor 3 out, I'll have 6 minus 7x at the top. And if I factor out a 7 in the bottom, I have 5 plus 3x in the bottom. That doesn't give us anything that we can cancel out. So we could have left it here or here. Both of these actually are mathematically correct. They're both correct. Okay, let's look at the next one. Solve the radical equation. How are we on time? Oh, short on time. I gotta go at 5. Okay, so this is one that does trip guys up, so let me definitely do this one. Okay, so solving a radical, we have square roots on both sides. So you want to start by getting one of those square roots by itself, which we do have that. So let's start by squaring the left side. If we square the left side, we've got to square the right side. So on the left, the square roots cancel, and I'll just have 41 minus 2x. But on the right, it's a little bit more going on. I've got the square root of 9 minus 2x plus 4 times itself. 9 minus 2x plus 4. You have to write it out like that so you can then distribute. So I'm going to have 2 times the square root of, no, I'm multiplying. So when you multiply two radicals that have the same, two square roots with the same denominator, sorry, I don't know what I'm talking about, I'm using all kind of wrong words. Two square roots with the same radicand, what happens is that you end up with just that radicand. So for example, if you have the square root of 7 times the square root of 7, that's the square root of 49, which equals what? 7. The square root of x times the square root of x is the square root of x squared, which equals x. So you can use that rule here. So the square root of 9 minus 2x times the square root of 9 minus 2x is going to give you 9 minus 2x. Alright? Then you have plus 4 square root of 9 minus 2x plus another 4 square root of 9 minus 2x, and then 4 times 4, 16. Okay, so we have 41 minus 2x equals all of that. Okay, so we have like radicals here. That's going to be 8 square root of 9 minus 2x. I'm going to bring down that plus 16 and bring down that 9 minus 2x. And 41 minus 2x equals. On the right, I have some like terms. I have 9 plus 16, which is 25, minus 2x plus 8 times the square root of 9 minus 2x equals 41 minus 2x. I'm trying to slowly get this square root by itself. So now let me move this 25 by subtracting 25 on both sides. And I can go ahead and move this negative 2x by adding 2x on both sides. So 41 minus 25 is 16. Negative 2x plus 2x cancels out, equals 25 minus 25 cancels out. Negative 2x plus 2x cancels out, and I have a positive 8 square root of 9 minus 2x. Alright, so that's basically 16 equals 8 square root of 9 minus 2x. I'm trying to get that square root by itself, so I'm going to divide by 8. So I'm going to have 2 equals the square root of 9 minus 2x. So now I have this square root by itself, so I'm going to square this square root. And so I'm going to end up with 4 equals 9 minus 2x. And then I'm going to subtract 9 because I'm trying to solve for x. So negative 5 equals negative 2x. And then finally divide by negative 2 to end up with positive 5 over 2 equals x. And that's going to be my final answer there. Whoop. Okay. Alright, let me skip to some that are a little different. I may not can work them all the way through. A rectangle is drawn, so the width is 9 inches longer than the height. Let's go ahead and sketch a rectangle. So the width is 9 inches longer than the height. And maybe I could draw it a different way so it makes more sense. Actually, it was okay how I had it. And now it's freezing. Sorry guys, my Surface Pro I think is getting tired. Come on back. Alright. Oh, come on. Alright. Alright, so it's saying that the width is 9 inches longer than the height. So we'll make the height x and the width 9 plus x. So it may help you to say that somewhere. So the height equals x and the width equals 9 plus x. And make sure that makes sense to you. So the width is 9 inches longer than the height. So that makes sense. If the rectangle's diagonal measurement is 45 inches, so diagonal is like this. That's 45 inches. Find the height. Okay? So we're going to use Pythagorean theorem. A squared plus b squared equals c squared. If it's a rectangle, that's a right angle. So A and B are your legs. C is always your hypotenuse. In this case, is 45. So you could say, x squared plus 9 plus x squared equals 45 squared. That would be x squared plus, you would need to multiply this out. What's 45 squared? 2025. that'll be x squared plus 81 plus, I'm going to kind of skip steps, 18x plus x squared equals 2025. That would be 2x squared plus 18x plus 81 equals 2025. And then from here, you'd want to set it equal to 0. So 81 minus 2025. That would be 2x squared plus 18x minus 1944 equals 0. And then from there, you would try to factor that, which would be crazy. So 1944 divided by 2, 972. This would be really long to factor. What I would do is probably use the quadratic formula. You get two solutions, and then you want the positive solution. If you get a negative solution, which you probably will, you don't want to include that in your answer. But I'm running out of time, so I'm going to kind of jump around and kind of mention some things. Quadratic formula, you need to remember that. Remember that is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Those variables are coming from the standard form of a quadratic equation. So in this case, your a would be 12, your b would be 5, and your c would be negative 2. Okay? You plug these values into your quadratic formula, and you will get two different answers, hence the plus or minus. Okay? All right. Quadratics. Remember that, okay, this is in what's called vertex form. Y equals a times x minus h squared plus k. The vertex is h comma k. The important thing here is to remember that when you're given vertex form, whatever it is in the parentheses, your h is the opposite of that, because the formula is x minus h. So this is x plus 2, so the h in this case is negative 2, and the k is the same. The way that I teach this, I say change the h, keep the k. So you change this to negative 2, and then you keep the k, keep that the same. So the vertex would be negative 2, negative 1. Now, whether the parabola opens up or down is based on the a. So if a is positive, it opens up. If a is negative, it opens down. That's it. So since 5 is positive, it would be up. Okay? Okay. If you are given the quadratic not in vertex form and you need to find the vertex, then you would use the vertex formula to find the x-coordinate of the vertex. So the x-coordinate of the vertex would be negative b over 2a. And then once you get that, to get the y, you plug in that negative b over 2a into x to then get your y. So for example, for this one, I'll just do this one here. So to get the x-coordinate of the vertex, that would be negative b, which is negative 12, over 2 times a, which is negative 1. A negative times a negative is a positive, 12 over negative 2, which equals negative 6. So the vertex would be negative 6, comma, something else. To get that something else, we got to take that negative 6 and plug it into our function. So that's negative times negative 6 squared minus 12 times negative 6 plus 6. So negative 6 squared is positive 36, You still have this negative on the outside. Negative 12 times negative 6 is positive 72 plus 6. So negative 36 plus 72 plus 6 equals 42. So the vertex here is negative 6, comma 42. Now, I want to show you one more thing before I let y'all go. And I want to show you how the graphing calculator can tremendously help you dealing with quadratics. So I want to show you how you could graph, say, this quadratic, this parabola, in your graphing calculator and answer a bunch of these questions. So, where's my calculator? I'll move it over here. Okay, so let's say I want to graph this parabola. So the way that you graph any function on the calculator is that you want to go to y equals. And so you want to make sure it's y equals or f of x equals. And you're going to plug in, type out that equation in here. So I have negative x squared minus 12x plus 6. Okay? I'm going to say graph. Now, depending on what your parabola looks like, you may not see everything. So you know this parabola is a U shape. Remember, our vertex we found was negative 6, 42. So that doesn't even look right based on what I have here. Okay. Okay, we'll see. All right, so now the way you want to change the graph to where you can see the whole thing, go to Zoom, and we're going to choose Zoom Fit. Oh yeah, it is good. Okay. All right, so it zoomed it in so we can kind of see what's going on here. And we probably, this is really weird. Let's zoom out some more. Wait. Okay, there we go. All right, so our calculator can tell us a lot of good information. So it could calculate the vertex for us actually. So if you see this trace button here, this calculate option, you do second trace, we can calculate all of this stuff. So the vertex for this parabola, since it's facing down, it's going to be the maximum. So we're going to choose this fourth option here. And now what it's asking you to do is kind of set the boundaries for where the calculator should focus to find the maximum value. So it's just kind of going along the curve. I want to move this to the left side of my maximum. So you see how it made like a little kind of barrier here, and now it's asking for the right bound. I'm going to move my cursor over to the right side of the maximum. Doesn't matter where you go. Enter. So now you're telling the calculator only focus on this region here. Tell me the maximum of this region on my graph. It's asking you, do you want me to guess? And you say, yes, I do. And you press enter. And then it tells you the maximum point. That's at negative 642. That's your vertex. So it found it for us. Okay, so now it's looking for the y-intercept. Let's go to second, calculate. And it's the y-intercept actually is easy. We can do that by hand. To get the y-intercept, you make x equals 0, solve for y. So in this case, the y-intercept would be 0 plus 0 plus 6. So the y-intercept is 0, 6. But for the values find the values that make f of x equals 0. So when f of x equals 0, that's when the graph crosses the x-axis, because that's when y equals 0. Okay? So the way that you can find out those numbers is by finding the zeros. the calculator finds the zeros, that's the same thing as the x-intercepts. That's the same thing as the values that make y equal 0. So you would do second, calculate, and you want to find a 0. You can only find one at a time, so you got to tell it which 0 you want to find. So find that left 0, the left value that the graph is crossing the x-axis. I'm going to set my bounds again. So I'm going to go to the left of that 0 and to the right of that 0, to the right of that intersection. So I want to find what this point is. And I can't tell by looking at it, but the calculator can tell me what that value is. So it's negative 12.48, comma 0. So it tells you to round 2 decimal places, so that would be negative 12.48. So you want to get the other one. We're going to do second, calculate. I want to choose another 0. It's asking for the left bound. So let's make this the left side, and I got to go over to the right side somewhere. So now it's going to only focus on this part of the graph. Press enter, and then it gives you that 0, so 0.48, comma 0. So those are the x values that make f of x equal 0, that makes y equal 0. But the calculator, knowing how to use the graphing calculator, can really help you answer some of these questions if you kind of have a block in terms of doing it algebraically. And that's important. It's helpful to be able to understand what these things mean so the calculator can be useful to you. Now that you can use it, you can do so much more with it than just like adding negative numbers. So I have actually run out of time, and I apologize, but hopefully this was helpful to you. If in your intermediate algebra Canvas class, you should have your turn questions for videos for every question in the textbook. So definitely watch those videos to kind of help you get an idea of how to work some of these problems out. Come down to the depot at the Osceola campus. We are open till midnight today, and then we're also open till midnight next Monday, Tuesday, and Wednesday. And then we're open on Friday until 5 o'clock, and we're open on Saturday 8 until 12 noon. We are here to help you. If there's no final questions, I just want to remind my online students that your final exam is actually available for you in the testing center now. You can go to any Valencia testing center, and it's due Thursday, okay? The final for my Ms. Forsyth's online intermediate algebra class is due on next Thursday. Anyone here who's not in my online class, definitely talk to your professor about when your final exam is. So if that's it, I'm going to go, and I will try to send an email out to the participants of the video. But it's been a pleasure. I hope this was helpful. And if there's no other questions, I'm going to sign off. See you guys later.